For thousands of years, many thought that the plague was a punishment sent by God himself. As such, it could be neither prevented nor cured. Medical practitioners thought that it was appearing by spontaneous generation, a theory that was prevalent up to the late 19th century. When Yersin arrived in plague-ridden Hong Kong in 1894, mandated by the French government and the Institut Pasteur, he was determined to apply a rigorous scientific methodology to find the cause of plague. The bubonic plague signature was the enlarged lymph node, or bubo. The lymph node would swell, becoming extremely painful, and indicate or herald a near-inevitable death. Yersin took samples from corpses and, looking at them under the microscope, identified the responsible microorganism or causative agent, a bacillus that was officially named Yersinia pestis in 1967. Yersin had proved that rats were carriers of the bacillus and deduced that they were a reservoir for this disease. But it is another Pasteurian researcher, Paul-Louis Simond, who demonstrated 4 years later, in 1898, that it was the fleas living on those rats which were the vector. The plague is spread among rodents, and from rodent to humans by fleas. A flea ingests the bacteria while feeding on the blood of an infected rat, and the bacteria multiply in the flea's intestinal tract. Soon the rat will die, and the flea will jump on another living rat. The bacteria present in the flea's stomach will form a mass that will block it and prevent further blood ingestion. The hungry flea will bite its host repeatedly, and during its attempts to feed, will inject the bacteria into the dermis of its new host. Humans bitten by an infected flea usually develop a bubonic form of plague. If the bacteria reach the lungs, the patient develops pneumonic plague, which is then transmissible from person to person, can kill in less than 24 hours, and bears an extremely high mortality rate. Yersin sent samples to the Institut Pasteur in Paris, and it was thanks to these samples that his colleagues developed an anti-plague sera that became instrumental to control the disease. In Madagascar, where the plague peaked in 1933, Georges Girard and Jean-Marie Robic worked on developing a vaccine. They succeeded in their task in 1935 and deserve high praise, since they carried out the first trials on themselves, at the time when no efficient medication was available once the disease had started. The death toll from the 541 AD Justinian plague pandemic is estimated at 100 million, while the 14th century Black Death is estimated at 75 million. The third pandemic, starting in 1855, killed over 12 million in India and China alone. Plague bacillus is considered one of the worst-known pathogenic bacteria for humans. We still don't know what makes it so virulent and how it overcomes our immune system. But recently, the Pasteur researchers discovered that the bacillus is sometimes infected by a bacteriophage virus named YPFV, or Y. pestis filamentus phage, that plays a role in its pathogenicity and virulence. The control of a plague epidemic is mostly a time issue. While the plague is extremely acute and necessitates an immediate treatment, the isolation and identification of the bacillus generally takes about a week, way too late for an efficient treatment. The Institut Pasteur in Paris and Madagascar have produced a reliable dipstick diagnostic test that takes only 10 minutes, does not require any sophisticated equipment, and can even be done anywhere. This represents a major public health breakthrough. Thanks to those pioneers' discoveries, the plague is no longer the devastating scourge it used to be. Nevertheless, to this day, it still has not been fully eradicated. Worse, it is even re-emerging. With nearly 30,000 human cases declared over the last decade, the plague is far from being a disease of the past. New antibiotics-resistant strains have been identified and characterized at molecular level. They show that the resistance genes carried by a plasmid are transmissible from one Y. pestis to another. Those results are highly worrying because this resistance is widely spread in other bacterial species commonly found in the environment and in retailed food products. The risk of other Y. pestis strains acquiring this antibiotic resistance should thus be seriously considered. Although a vaccine against plague developed in the 1930s was highly valuable when no treatment was available, this vaccine was phased out because it had severe side effects and did not confer long-term protection. Several teams worldwide are currently working on the development of a new one. But to this day, there is still no safe and efficient vaccine available against the terrible Black Death.